This is Mr. Hanna. Welcome to What the Format. Today we're going to go over direct variation. Direct variation is proportionality when things are in a set ratio. There's two types of variation. There's direct variation and inverse variation. And then there's a combination of those as well as double direct variation is what I call it, where you have joint variation, but it's still just a version of direct variation, just more variables. So in direct variation, you'll notice that one variable is equal to a multiple of the other, okay? So you're multiplying some variable by a number to get another number, and it's constant. This k is called the constant of proportionality. So when they say find the constant of proportionality, what they're saying is find k. Now you'll notice I've divided it up into two parts. Part one, find k, and then part two. That's the way a lot of math problems start to work, okay? We saw this with sequences. If you watch the sequences video, for arithmetic sequences, you have to use the sequence to find d. Once you find d, then you plug it in to find your explicit formula, and then you can use that to find any number in the sequence. So you've got parts to it, layers to it. Any one part is wrong. You get the d wrong because you miss a sign or something, or you simplify incorrectly, then the whole problem is wrong. All right? Well, direct variation is similar to that. There's two parts. So they're going to give you this phrase: y varies directly with x. Okay? Now, fair warning on this, sometimes they'll change up the y and the x. It doesn't really matter which one they use. The one that varies directly with is always on the left. The one that is here goes after the k. So this could be like one of the famous formulas is distance equals rate times time. Well, that's a direct variation equation. Distance varies directly with time. The rate is then constant. At least in a lot of algebra situations, they make the rate constant so that way you can use that as well. So that's an example of them changing the variables. But for learning this, it's best to stick with y and x. Why? I think I mentioned this in a video prior to that. That's what they use all the time. The more comfortable you are with the variables they use on a regular basis, the easier algebra will be to pick up for you. So with direct variation, you're going to see this language. Y varies directly with x. What we do then, it says find the constant of proportionality if y equals 12 when x equals 2. So what do? Well, we very simply plug the 12 in for y, substitute, and substitute the 2 in for x. Now when we do that, we're going to get y, we got to substitute. So y is now 12. 12 equals k times 2. And then when we're solving, we do our reverse PEMDAS. And with this situation, it'll always be undoing our multiplication here. So the opposite of multiplying is dividing. That cancels. What I do to one side, I do to the other. 12 over 2 is 6, and our 6 equals k. And guess what? That's the first part of the problem. There's your answer. Find the constant of proportionality. Now, that gives us an equation. This is constant, it doesn't change. So we can plug it back in for k, and so now we have this equation over here. Y equals 6x. Now, if k changes, then this equation will change. And k can be any number. It can be a decimal. It can be a fraction. It can be, usually they don't make it negative, but technically speaking, you can have a negative because you can go down in a relationship. Usually they keep it positive. And in fact, now that I'm thinking it through my head, it should always be positive because direct variation is only direct variation if it goes through the origin. And the only way to go through the origin with direct variation is if then you go positive. So this should always be positive. If you ever see it negative and they call it direct variation, then you know that they've made a mistake. Which I mention that because sometimes why I get confused even is because I've noticed a lot of times in different curriculums they've changed a few things. And they say it works, but if you look at the rules from past, it doesn't really work. So I hate that confusion exists, but sometimes it's there. So that's something you always want to think through though. As you're learning a concept, you want to ask yourself, wait, can that number be negative? What can it be? So it has to be positive. It has to go through the origin, 0, 0. So when y is 0 and this is 0, okay? And you can't do that with a negative number because then your line goes down and then you're into negatives. And most situations, y and x isn't negative. We're usually applying this to real world situations. So I guess what we'll say is 99% of the time, this is going to be positive. If it is negative and things are going down, that would be an unusual situation. Of course, now that I say that, the first time you come to a test with direct variation, they're going to make that negative. It's just the way life works. But 99% of the time, this is positive. You have to go through the origin. Once you have this, y equals 6x, then you can find either y when x is a number, or you can find x when y is a number. Well, how do you do that? Well, all you have to do is substitute. So here x is 7. So if we substitute 7 in here, we have 6 times 7, which is 42. So there you go. Right here, we're going to have y equals 6 times 7. So y equals 42. Straight multiplication, no big deal. Now down here, we're going backwards. We're saying y is 48. So what you're going to do, again, is substitute 48 for y, and you have that equals 6x. So now, instead of multiplying, we're going to divide here over 6. 48 over 6 is 8. So you get 8 equals x. And that's how they do direct variation. So the real trick then is this part here. You got to make sure you find the k right. Because given any x, at that point you just need to be able to multiply numbers, either in fraction format or decimal format or an integer format. And then if they give you the y and you want to find the x, instead of multiplying, you just divide. 2 parts. If you know what you're doing, it's not too bad. Again, know your boundaries. Okay, those are things you want to ask when you're learning something, because if this number is negative, that kind of changes things, doesn't it? And especially if you start trying to graph that and think through it, it can get more confusing depending on the complexity of the numbers that you can use. Certainly it gets more confusing if you use decimals or fractions there. I want you to learn the concept first and worry about the actual math later. So this is the concept. This is how you recognize you're doing direct variation. Because you'll see y varies directly with, or it'll say y is directly proportional to x. That is another way that they will say it. So if you see varies directly or directly proportional to, you're using this equation. This is your base equation, y equals kx. And they use k. Why? I don't really know. Never really figured that out, but I don't need to. The minute I know what they call it, I just have to remember they call the constant of proportionality k. And once I have it, in that situation, for that relationship between those two variables, it does not change. Okay? And again, 99% of the time it should be positive. So start with positive numbers, get comfortable with it. Once you're comfortable with the concept, if they do some weird things, like if they say factor 3, and you have to factor it to the square root of 3 times the square root of 3, normally they don't do that. But if you're good at factoring and you've gotten comfortable with the topic, then when they do something oddball like that, you're able to adjust. Okay? So basically think of it like level of difficulty. You want to start off with the easiest level of difficulty until you get the concept down and you're comfortable with it. Then you can start playing with different variations of that. But always start with the simple. This is the simple part. K is going to be positive. We did part 1, then we part 2. And you don't pick these numbers. They'll tell you whether to find y when x is this or find x when y is this. And it could be one or the other or both. It just depends on the problem. Anyway, hopefully this has been helpful. This is direct variation. This has been Mr. Hanna with What the Format. Happy mathing.